Catalysis Society. My name is Alex Mills, University of Delaware, and I'm your session chairman and first speaker for this morning, where my task in the speech is to give some concept of the symposium and prepare the way with background for our four speakers who will be addressing the future. We'd like to think that this symposium is a challenge for catalytic scientists to propose future directions, new ideas to fulfill the needs of society. It's also a challenge to recognize the new activities and scientific capabilities of catalysis and see how these could be applied to the needs that we have in a practical manner. I think, as a matter of fact, unless we respond to this challenge, we will not at all live up to the potential which we have. This symposium is different from the rest of the particular meeting here in three important ways. First, it deals with the future, not the past. Secondly, it is concerned with applications, if applications to fill needs, and we will be looking to these in various objectives, not only economic, but in health and other aspects. At the same time, of course, we do recognize that besides the applied side, there's a great need for science of catalysis, a great need in the sense that it's a valid objective in its own right, but even further than that, it's completely needed to provide the basis for future developments. The third aspect of this particular meeting is that it provides, at least to some extent, a forum for any comments you want to make on the relationship between science and technology and how this can be improved. Actually, the inclusion of applied catalysis is not new in meetings of this. In some of the early meetings, for example, in 1960, Val Hansel was chairman of a complete section with some 25 papers in it on applied catalysis. And of these papers, there were quite some significant ones. For example, Kirby, who talked about aluminum phosphates, which is certainly a topic of today too. There were a couple papers on smog catalysis for smog abatement. We had Callahan talking about selective oxidations of propylene to brine, which led ultimately to nitrile synthesis, and others of long-term significance. I say that it's timely to discuss future direction for catalysis with at least three conditions. First of all, there's a changing conditions in the world which we've seen, particularly the decrease in oil prices. This is a very serious matter as it impacts on synthetic fuel, because synthetic fuel was indeed one of the sustaining activities for catalytic research. But actually, this is really a short-term situation, because energy fuels remain of critical and growing criticality in our future. Actually, I think that the pendulum is swung back somewhat in the sense that there is new interest in syn fuels, and we're beginning to hear voices like Abelson, Hersh Barco, and Michel Halboudi, who recognize that, in fact, this country does not have an energy policy. Another feature is that past successes have changed catalysis. It's sort of a paradox that we've been so successful and, in fact, solve these problems. But again, there's a great need to do new things. It's also said that catalysis is mature, that there's not much chance of a breakthrough, that new products are not being found. But actually, there are few innovative ideas, but I think that you find, and I hope you find as a result of the symposium, that in fact, there are many things that have happened, and the record is showing that actually there's been a rapid and continuing place for new inventions which are finding their way in a very practical sense. It's also said that instrumental research is expensive and not cost-effective. Well, what is true is, in fact, that instrumental research and characterization has been of critical importance course, it's also true that more than ever, with the proliferation of expensive equipment, the planning and execution of research is of increased importance. Just when we think that there's no innovation, we see not catalysis, the breakthrough in superconductivity and organic structure for superconductivity, which you can see are opening the way to vast opportunities, and there are certainly opportunities in catalysis which are similar. Our response, we like to believe, is to generate ideas from the catalytic community to reassess their needs and capabilities, to look for these future directives, and see how the interaction between the science of catalysis and development would be possible. Now, there's an important connection between the support for research and the benefits to society. Actually, the past record has been one of a great relationship in the sense of support on the one hand and benefits to society. I went back and I thought it was interesting in the Miami International Congress that Hansel and Borisov and I each made independently significant remarks about the contributions of catalysis. Borisov said specifically, quote, "Catalysis has provided the scientific basis for technological progress in a variety of areas and has materially benefited humanity." End quote. Actually, at that particular Congress, prevention of pollution and provision for energy needs were particularly stressed. The second point, by the way, that was made there is that there is a gulf between industrial and academic sectors. And I must say this gulf still exists today, and there's an opportunity to think how, in some new creative way, to do something about that. I would say that the creation of academic research centers in this country has gone a long way with the participation of academicians and industrial people to satisfy this improved interaction. Now, I want to say something about the Pimentel report. And this is a creative way of spending Pimentel, I see. I would like to think that our meeting today is a follow-on to the Pimentel report. Pimentel report, which is opportunities in chemistry, under the heading Control Chemical Reactions, says this: the prime reason for wishing to understand and control chemical reactions is so that we can convert abundant substances to useful products. And as you can read, it also mentions the fact that these advances will have great economic and technological impact. What I think is needed, and why I start with the Pimentel report, is that this is why is the basis for making suggestions that are much more specific. And I hope today that what we will hear are much more specific and meaningful suggestions for carrying out the general statements of the Pimentel report. The Pimentel report also says, of course, that they make five recommendations in 5 areas, one of which is chemical catalysis. And as you can see here, they're proposing things that I think each of us would subscribe to in the language. It includes heterogeneous, homogeneous photocatalysis and artificial enzyme catalysis. And again, our principal objective will be to provide this fundamental knowledge, creative manpower to function in a applied way. The Pimentel report also says some quite positive things about the developing of insights that have occurred, the capability to see molecules on surfaces that are reacting, metallo-organic compounds with purposeful, specific, steric specificity and reactivity, which can form highly selective activity conversions. We also look forward, by the way, to the Amundsen report, which is a short title,